This project is in collaboration with Oxford Biomedical Engineering Society, and how it started was that we were introduced by the head of department, Ross Attia, and I got in touch with the Oxford side, and they were very supportive and keen on the idea of the proposal that I passed to them. And so we started from having exchange programs between Imperial and Oxford, and got to know each other better and set out the terms and also aims and objectives of this event. Bioengineering Day was wanted to make UK realize, because different from US and a lot of other places, bioengineering is not that a popular field of studies in UK yet. And we want people to realize that this field is up and coming and there's a lot of potential. We realized along the way that such a motivation has to come from both internal and external. So on the inside, we like to motivate the students, and from the outside, then we want to propagate the message of what potential applications and innovations can come out from bioengineering.
My name is Sandra Scheffelbein, and I'm a bioengineering lecturer in the Department of Bioengineering at Imperial College London. Got interested in bioengineering because I'm interested and fascinated by the human body and how the human body works. So in medicine in general, but I really like math and physics, and so bioengineering is a way to combine math and physics and medicine together using technology to look at the human body. Bioengineering is a fascinating subject because it's so interdisciplinary. It combines mechanics, which is my focus. It can combine electronics engineering, neuroscience, biology. All of these things go into the whole realm of bioengineering. So as a student in bioengineering, you learn all these topics, and as a researcher in bioengineering, it's a very broad base, and I have collaborations with biologists, anatomists, physiologists, and doctors as well.
I guess the most interesting part about bioengineering that I've gained technical-wise over the past few years is the ability to relate to a whole range of different subjects out there, because I find it so exhilarating that when I meet a medic, or when I meet a physicist, or when I meet a computing person, I can speak their language, I can understand. I realize that, okay, people can be right in saying that bioengineering, you learn things in a more broad spectrum for everything. You can say that we are a jack of all trades, masters of none, people, and also to understand the same concept from different angles.
I think bioengineering is really exciting because it's so broad. You have people in all departments over at Imperial doing something that's bioengineering related, and it really is the new up and coming field because we have a good grasp of the physical world, but that biology, what's actually going on in the cell, is still an unknown. People just don't know, and by using engineering techniques, we're really starting to understand how biology works. And I think it really is the new frontier of science, is applying engineering skills to understand living matter.
Oh, I gained so much from bioengineering. I would say that it changed me a lot, this whole degree. It's because of the intensive training that we get, especially second year. I mean, everyone in bioengineering will tell you that that is the toughest year around. And that is toughest because of the very intensive training that the department's trying to give to the students. And for me, it was the really tough year, but I gained so much from it. Not just because I dealt with all the projects and coursework that the department has installed for us, but also because of the process of working with my friends. Enjoy the process.
So for me, one thing that's emotionally rewarding is actually the teaching. I really enjoy teaching. The research is rewarding as well, but it's a lot further down the line once you actually publish a paper or you come up with a therapy. It might be 10 years down the line, whereas teaching is immediate. And so I really enjoy the teaching when the light bulb goes on and you see the students say, oh, I get it. I find that very rewarding. In terms of research, most of my research is a couple steps removed from actual clinical application. So I look in animal models of a disease. How can we fix the animal model, which will eventually be translated into clinical research or clinical application. So the actual application to humans I find very rewarding, but that comes much further down the line. But most of my research has some kind of clinical application eventually.
Bioengineering Day. It is a platform that we actually brought together students from year 1 all the way to undergrad, all the way to MSc. And I really like this kind of working group dynamics because you get so many different inputs and ideas. This year is drawing to a close, and Bioengineering Day is probably a very good way of ending the year, I guess.